In this video, I will solve three numericals on Z transform. We have here x of n discrete signals. We are supposed to calculate the Z transform of each signal. Let me consider the first signal, that is this one. We know that the Z transform of any discrete signal x of n is represented as x of z, and x of z is given by, that is x of z is equal to summation n is equal to minus infinity to infinity x of n z power minus n. Simplifying this, that is x of z is equal to summation n is equal to minus infinity to infinity. We have x of n is this signal, that is 0.5 power n u of n plus 2 power n u of minus n minus 1 z power minus n, or I can further simplify this as summation n is equal to minus infinity to infinity. We have 0.5 power n u of n z power minus n plus, I will split the summation. Similarly, n is equal to minus infinity to infinity 2 power n u of minus n minus 1 z power minus n. Let me simplify this further, or I can represent this as summation. Here u of n indicates the signal is right sided signal. For n less than 0, the value of the signal is 0. Therefore n varies from 0 to infinity. 0.5 z inverse power n. Similarly, here u of minus n minus 1 indicates that the signal is left sided signal and it varies from minus infinity to minus 1. That is, for n greater than minus 1, the value is 0. Therefore, here n varies from minus infinity to minus 1. We have 2 z inverse power n. Further, I can simplify this as summation n equal to 0 to infinity 0.5 z inverse power n plus, here I can represent this as n is equal to infinity to 1. If I consider n as a positive values of limit, then we are supposed to replace this n by minus n, that is 2z inverse power minus n, which is same as this expression. Let me continue here, or I can write it as x of z is equal to summation n is equal to 0 to infinity 0.5 z inverse power n plus summation n is equal to 1 to infinity. Here this can be represented as 2 inverse z power n. We know that summation n is equal to 0 to infinity alpha power n is equal to 1 upon 1 minus alpha, and summation n is equal to 1 to infinity alpha power n will be alpha divided by 1 minus alpha. Now let me apply these two formula here. Therefore I can write x of z is equal to, here alpha value is 0.5 z inverse, that is 1 upon 1 minus 0.5 z inverse plus, here we have alpha is 2 inverse z. 2 inverse means 1 by 2 z divided by 1 minus 1 by 2 z. So this is the z transform of given function. Let me consider the second example. So x of z is equal to summation n is equal to minus infinity to infinity x of n z power minus n, or we can represent it as n is equal to minus infinity to infinity. Here x of n is 2 power n u of minus n minus 3 z power minus n. Here u of minus n minus 3 indicates that the signal is left-sided signal, and which starts from n is equal to minus 3 up to minus infinity. It means the n varies from minus infinity to minus 3. Therefore, I can represent it as summation n is equal to minus infinity to minus 3 2 power n z power minus n, or I can represent it as summation n is equal to plus infinity to 3, provided that I will replace n by minus n, which is same as this one, that is 2 power minus n, and this is z power n. Or I can represent it as summation n is equal to 3 to infinity. Here we have 2 inverse z power n. So simplifying this, I will get x of z is equal to, so here n is equal to 3, that is alpha power 3 divided by, that is summation n is equal to 3 to infinity alpha power n is equal to alpha power 3 divided by 1 minus alpha. Similarly, here alpha value is 2 inverse z. 2 inverse means 1 by 2 z power 3 divided by 1 minus 1 by 2 z. So this is the z transform of given signal. Now let me consider the third example. X of n is equal to sine pi n by 8 minus pi by 4 u of n minus 2. So here I can represent this x of n as x of n is equal to, we have sine, here I will represent it as pi by 8 n minus 2, which is same as pi by 4. U of n minus 2. For easy simplification, we'll solve this problem using Z transform properties. We know that sine omega naught n u of n, its Z transform is given by sine omega naught into Z inverse divided by 1 minus 2 cos omega naught Z inverse plus Z power minus 2, having ROC greater than 1. So here one should remember this formula. Now I can write sine pi by 8 n, the Z transform of this will be, that is u of n, the Z transform of this will be, here omega naught is nothing but pi by 8. I will replace omega naught by pi by 8, so that I can get sine pi by 8 Z inverse divided by, we have 1 minus 2 cos pi by 8 Z inverse plus Z power minus 2. Now by using time shifting property, that is use time shifting property of Z transform, I can write it as sine pi by 8 n is replaced by n minus 2, u of n minus 2, the Z transform of this will be that is shifting property, shifted by 2 units. So we supposed to multiply this entire term by z power minus 2 as it is shifted by 2 unit. Z power minus 2, the remaining term will be as it is, that is sine pi by 8 z inverse divided by 1 minus 2 cos pi by 8 z inverse plus z power minus 2. This is the z transform of given x of n. Thank you for watching.